Hello student, welcome back to the second part of our lesson whole numbers. In our previous session we have learned what are whole numbers and their properties. Now in this video we are going to learn about the addition and subtraction of whole numbers. So let's see what we are going to study today. So in this session we are going to study the properties of addition of whole numbers and the properties of subtraction of whole numbers, and then it would be followed by the exercise. Properties of addition of whole numbers. So here let's start with the first property. The first property is known as the closure property. The closure property states that the sum of any two whole numbers is always a whole number. What does it mean? That if we add any two whole numbers, then the answer is also going to be a whole number only. So let's understand this closure property with the help of few examples. Say here I take two numbers, that is 3 and 5. 3 plus 5. So both 3 and 5 are whole numbers. If I add them, then I will get answer as 8. So 8 is also a whole number. Now let's take one more example. 2 plus 0. Now we have seen in our previous video that 0 is the smallest whole number. So 0 is also a whole number. So if I add 0 to any number, I get the same number, that is 2. So again this is a whole number. So this is what closure property means, that if we add any two whole numbers, the answer is going to be a whole number only. Now let's see another property, or the second property, which is known as the commutative property of addition. Now commutative property of addition says for any two whole numbers a and b, the sum a plus b is equal to b plus a. Now what does this mean? This means if I take any two whole numbers and add them, then the sum remains same irrespective of the order of the two numbers. So if I write a plus b or I write b plus a, the sum is going to be same only. So let's see an example. Say I have two whole numbers 2 and 7. So when I add 2 plus 7, the answer is 9. Now if I change the order, I write 7 plus 2. Then again the answer is 9. So this is what the commutative property means, that if I change the order of numbers, even then the sum is going to be the same. Now let's see the third property of addition. Associative property of addition. Now associative property of addition says for any three whole numbers a, b and c, the sum a plus b plus c in brackets is equals to a plus b in brackets plus c. Now what does it mean? It means that if I am adding any three numbers, then grouping of number doesn't change the sum. That means whether I add b plus c first and then add it to a, or I add a and b first and then add the sum to c, then the answer is not going to change. Now let's understand this associative property with the help of an example. Now here I have taken a as 5, b is 2 and c is equals to 3. So now let's write So now here I have first adding 5 plus 2 and then adding it to 3. Now here 5 is added to sum of 2 and 3. So let's first solve the brackets. 5 plus 2 will give me 7 and this 7 is then added to 3. Now in this side add 2 and 3 first since they are given in bracket. So this sum is equals to 5. Now 7 plus 3 is equals to 10 and here 5 plus 5 is also equal to 10. So changing the grouping doesn't change the sum. Ultimately we are going to get the same sum. So sometimes this associative property helps us in addition of many numbers. If I am adding a large number of numbers together, then associative property is helpful for their addition. Now let's see the fourth property, that is identity element. It says when 0 is added to any whole number, we get the same number as the sum, or the sum is the number itself. So we can write for any whole number a plus 0 or 0 plus a is equals to a. That means adding 0 gives me the same whole number. So let's say for example 7 plus 0 will give me 7 and 0 plus 7 will also give me 7. So adding 0 doesn't change the identity of the number, or I can say adding 0 doesn't alter the number. That's why the number 0 is called the additive identity of the whole numbers. Now let's see the application of properties of addition. Now in the previous slide I have told you the associative property of addition helps us in the addition of many numbers. So if I have to add many numbers together, then we can do proper grouping so that addition becomes easier. So let's see it with the help of an example. Add the following using suitable rearrangement. Now here the numbers are 1 plus 2 plus 3 plus 4 plus 896 plus 897 plus 898 plus 899. Now here if I add it as it is, then it would take a lot of time to add them. So now I would do suitable rearrangement. Now you can see when I add 1 to 9, it gives me 10. So I group these two numbers 1 plus 899. Now 2 is grouped with 898. 3 is clubbed with 897 and 4 with 896. Now let's see what we will get. 1 plus 899 gives me 900. Here again 900, 900 and 4 plus 896 also gives me 900. So now add these numbers together, I will get 3600. Now if I would have added it in conventional method, then it would have taken a lot of time to add this number. So when we have to add a lot of numbers, try to group them in such a way that addition become easy. Always keep it in mind. 1 is friend of 9, 2 with 8 gives me 10. Similarly 3 and 7 gives 10. 4 plus 6 gives 10. 5 plus 5 gives 10. So try to make such pairs, group them together so that the addition becomes easier. In this way we can use the associative property of addition to solve such problems. Now let's see the properties of subtraction of whole numbers. So the first property is closure property. The closure property of subtraction says the difference of two whole numbers is not necessarily a whole number. For any two whole numbers a and b, the difference a minus b is a whole number only if a is greater than b. Hence, the closure property does not hold true for the subtraction of whole number. Now let's understand it with the help of an example. Say I have two whole numbers 5 and 3. I write 5 minus 3. Then the answer is 2, which is a whole number. So here you can see that the first number 5 is greater than the second number. So I can always subtract a smaller number from bigger number and the answer will be a whole number. But if I write 2 minus 7, that means the first number is smaller than the second number. Then what will be the answer? The answer is not a whole number. We cannot subtract a bigger number from smaller number. That's why we say that the closure property is not true for whole numbers. In every case, if I try to subtract any two whole numbers, the answer is not necessarily a whole number. Now let's see the other property, that is the commutative property. Now for any two whole numbers a and b, the difference a minus b is not equal to b minus a. That means changing the order of numbers does not give me the same answer. We have seen that the addition is commutative, but subtraction is not commutative. If I change the order of whole numbers, the answer is not going to be the same. Let's see it with an example. Say here I take 7 minus 3. Then the answer is 4. But again, if I interchange the order 3 minus 7. Now 7 is bigger, so I cannot subtract a bigger number from smaller number. So this is not defined, or I can say it's not a whole number. So these two differences are not same. So we can say subtraction of whole numbers is not commutative. Now let's see the next property of subtraction, the associative property. Now it says for any three whole numbers a, b and c, the difference a minus b minus c in brackets is not equal to a minus b in brackets and then c subtracted from it. Now let's understand it with the help of an example. So here in this example I have taken a as 10, b is 3 and c is 2. So now let's see the first case, 10 minus 3 minus 2. So here 3 minus 2 is in brackets. So I have to first find its value. So 3 minus 2 will give me 1. And then this 1 is subtracted from 10. So 10 minus 1 gives me 9. Now let's take the other side, a minus b in brackets and then minus c. So here 10 minus 3 in bracket minus 2. So first subtract 10 minus 3, which gives me 7. And then I subtract 2 from the 7, which will give me 5. Now you can see 9 is not equal to 5, or I can say the two answers are not same. So in this way I can say the associative property of subtraction does not hold true in case of whole numbers. Now let's see the last property, that is property of 0. It says for any whole number a, the difference a minus 0 is equals to a, but 0 minus a is not defined. Or I can say if I subtract 0 from any number, then the difference is that number only. This is what 0 property means. So let's see with an example. 8 minus 0 is equals to 8, whereas 0 minus 8 is not defined. So in this way, the 0 property says if I subtract 0 from any number, I get the same number, but I cannot subtract any whole number from 0. So students, I hope you have understood the properties of addition and subtraction of whole numbers. Now you can solve the following exercise on the basis of the knowledge which we have gained today. So that's all for today's session. Thank you, children.